Alright, let's solve some more quadratics. So you've seen how factoring works, and now let's look at a couple more examples where initially it looks maybe a little different, but ultimately we are still going to have to factor. So the first one here has fractions in it, and most of us don't really like fractions. So one thing that you could do here is you could use b plus 2 and b plus 1 as a factor. So if I look at this first one here, then these two will cancel. The b plus 2 will cancel, leaving you with the b plus 1. So out of the first fraction you get that. Then plus 1 times this mess. So we will have to FOIL that. And then finally on this side the b plus 1 is going to cancel here. So that leaves you a 4 and then a b plus 2. Okay, distribute. So 3b squared plus 3b plus b times b is b squared. You get 1b plus 2b is 3b, and 2 times 1 is 2. Excuse me. Same thing on this side. Bring everything to the left. So 3b squared plus b squared is 4b squared. I'm going to cross things out as I do this. 3b plus 3b is 6b. But then you're going to subtract 4b from that, so that leaves you 2b. So I did those, did that, cancel that, and 2 minus 8 is going to be a -6. Okay, so now we need to look at how do we factor this. First thing is that they all have a 2. So although these problems, you'd still end up with the right answer even if you didn't take the 2 out. It's just a good habit to look for common factors. And then 2 has to be a 2b and a 1b. And then that's a 3, so we're going to need a 3 and a 1, and one of them has to be negative. So let's see, let's put the 3 here, and if I put the negative 1 there, I'll get 2b times a negative, that's negative 2b plus 3b, so that will work. Well, that means that 2 is equal to 0, which it's not, or 2b plus 3 is equal to 0, which only happens when b is a negative 3 over 2, or b minus 1 is 0, which occurs when b equals 1. So those are my two answers. Number 2, the 6 is on the wrong side, so don't try to factor this thing, always make sure that you get it to say equal 0. In this case, they both have a 5 in common. 20 divided by 5 is 4. And then you can see one of our very common patterns. Sorry. And so, again, either 5 is 0, which it's not, or k plus 2 is 0, or k minus 2. So keep in mind that we often write it this way then. Okay? 2 more examples. So this is sort of a new one. There's more than one way to solve this, so I'll show it sort of the long way. So first thing, because I just said always make it say 0. So subtract 10 on both sides, you get this. Now that may not look factorable, but we can still write this as y minus and y plus. Now if that was 16, we would put a 4 here, because the square root of 16 is 4. And that's sort of the key here. If you just write the square root of 14 here, it'll still work. This will still have a positive 14, or square root of 14 times y, and then a negative square root of 14 times y. So we still get a cancellation. So plus or minus the square root of 14 is one answer that you could give, or one way that you can get that answer. Sort of as a preview of what we'll do later is you can just move it to the other side by adding 4, and then when you take the square root, then the trick here is that you have to remember to use a plus or minus. Okay, we may see that easier with, for example, well, what if it said y squared equals 4? Well, most of you are probably just going to say, well, make y equal worth 2, and that will work, because 2 squared is 4. But hopefully you would also agree that a negative 2 would still squaring it give you 4. So when you take a square root, you do need both the positive and the negative. Okay, so we can use that here really fast, and we get m squared equals 4, and then m equals plus or minus the square root of 4. So m is plus or minus 2. If you brought the 12 over and then divided by it, 12 divided by 3 is 4. So then we could write it this way, and then you could still see that we do get the pattern. But that's clearly taken a little while. Okay? Alright. Thanks.